I think is probably the most important today. This paper that you have in front of you, we're going to be working on this over the next 2 days, so we're not going to stress it too much. But I want to show you a different way that this could be challenging. What unit should wavelength be in? So it should be in meters. But it may be given in centimeters or nanometers. Which is problematic. They're going to give it to you in a different way. However, you have to convert it to meters. Must convert it to meters. Put some dots around it. Find a little design, happy face. Take a guy, give him a mullet. I don't know what you need to do. Somehow, this has to be remembered. I'll remind you how to do this real quick. We've done this before, we've been here. I'm going to give you your conversions to make it simpler on you. Here you go. 100 centimeters is in 1 meter. Y'all remember that one, right? It's about 3 or 4 weeks ago we did this. Another conversion that we didn't do, but now I'm going to give it to you, is that there are 10 to the power of 9 nanometers for every 1 meter. So what do you have? Your conversion factors. Excuse me. So here's what we will look at. We are going to look at converting centimeters or nanometers to meters real quick. I'm going to give you an example or two. Convert 9.932 centimeters to meters. Let you write that down real quick. Okay, so we put the 9.932 in our top left box. What unit has to go on bottom here? Very good, you remembered. What unit has to go on top? Very good. And there's 1 meter for every 100 centimeters. Remember, what do we do now? Multiply the top 2, 9.932 times 1. Then divide by the bottom, which is just 100. 0.09932 meters. Let's look at a different example. Convert 3.18 times 10 to the 10th nanometers to meters. Let you write that one down real quick. What number is going to go in our top left box? Times 10 to the 10th, right? Nanometers. What unit has to go on the bottom right now? Very good, nanometers. And there are 10 to the 9th nanometers for every 1 meter. I know this relationship because we had just gone over it right above. These are your conversion factors. 3.18 times 10 to the power of 10, put it in parentheses. Divide it by 10 to the caret top 9. Put that in parentheses. 31.8 meters. This entire day, you have to be 100% certain that you are watching the parentheses. Always watch the parentheses. Because if you skip it, you'll upset the PEMDAS. Cool? If you'll go back to this worksheet real quick. You can skip questions 3 and 4. We're not going to work on those on the front. Now, but let's go through question 5 real quick. It says, the longer the wavelength, the blank the frequency. Bigger wavelength equates to what? Smaller. They're inverse relationships. So longer wavelength, the shorter or smaller the frequency. And what type of relationship is this? Indirect or